relation is a set of ordered pairs, and it can be represented many ways. So we can represent a relation as just ordered pairs. Now, this relation can be random ordered pairs, or the relation can be made up of information like your height, comma, how many cookies you ate yesterday. It doesn't really have to make sense. It can be a combination of any two things we want it to be. Okay, so we've been talking about ordered pairs. Okay, we gave those info yesterday where every ordered pair is an X, comma, Y. Hi, Danny. I'm fine. What's up? Yes. Yep, I'll send them when we finish notes. Bye.
So funny.
Me?
No, not you. No. Sorry.
Okay, so each of these individually is an X and Y coordinate, right? You okay with that? We can then take that information and represent it in different ways. Why? Because sometimes it's useful to look at things in different formats, right? Whether it's a bar graph or a line graph or a pie chart or, right? We talk about different representations of things all the time. Depends on what's maybe useful in the situation we're given. Right now it's going to feel a little bit pointless, but as we get to data, it'll be more useful. Okay? So we should also know that we can do a table, and I'm not really sure where this came from, but more and more recently my students call these T-charts.
Yeah, T-shirt.
Yeah, this is a table.
T-shirt? T-shirt.
I don't care. I do not care. Too tired.
Okay, it's a table. It's a table.
No.
Okay, so we can take our ordered pairs. So if this is the ordered pair 1, 2, I can place it in my table. Now, oftentimes when we look at tables, we will see our X value from least to greatest, but it is not a requirement. The only requirement in the table is that your X value is sitting next to its corresponding Y value. So 1 goes with 2, 1 goes with 2. 3 goes with 7, 3 goes with 7. Okay, are we okay on that one? That one's a pretty normal one we've seen before. Our third representation is the one that is completely new to us, and it is called a mapping. Okay, a mapping consists of these sort of two ovals, bubbles, where we put all of the X values on the bubble on the left, and we put all of the Y values in the bubble on the right. Now, when I said terminology and things we need to know, here's one of our first big ones. When we create a mapping, we need our numbers to be in numerical order. What does numerical order mean?
Like
In order from 1 to
Right, least to greatest. And we can have no repeats. Which means if we see a duplicate number show up as an X value, we can't write it twice. Okay, so I'm going to show you where that mapping came from. If I look at these ordered pairs up here, my original representation, okay, I'm going to go down the list and take just the X values. So 1, 3, and -4 are just the X values. So those are going in my first oval. And in that oval, I need to put them in numerical order, right? So my smallest one is -4, +1, +3. Okay, then in my right oval, I'm putting all my Y values. So 2, 7, and 6. And I'm listing those in numerical order as well. Then it's sort of like connect the partners. I don't know. So we're going to draw a line, draw an arrow to its partners. So 1 goes to 2. So I'm drawing a line from 1 to 2. Right? I'm drawing a line from -4 to 6. And I'm drawing a line from 3 to 7. Does that make sense? Yes.
Do they have to be like going to the right?
I don't know what you mean by that question. Try it again.
The arrows, do they have
No, I mean, even if it's just a line, it's fine.
They have to be in order from least to greatest.
Right, going this way, your X values need to be from least to greatest. Yes?
I feel like it only goes to the right because it's X, then Y.
To Y, yeah, we're going to talk about some other things in there too, so. Our fourth option is that we can graph. This is what we were just practicing yesterday. This is just taking those ordered pairs and plotting them. So you're going to have to pick up your pencil and you're going to have to plot the points. I didn't plot them for you. So what do we have? We have the ordered pair 1, 2. We have the ordered pair 3, 7. And -4, 2. Do not connect the dots. Okay, yesterday we connected the dots in the activity. Okay, but this only has 3 points that are part of it. So there are only 3 dots on the coordinate plane. We're going to talk a whole lot more later in this unit about what we need to happen for there to be lines or circles or squiggles. Yes?
You plotted -4 to its -4.
Oh, what is it? -4, 6. Sorry.
Yeah.
I was just
I'm
trying.
confused.
I was just trying to memorize things.
erase like a...
-4, 6. Is that what it is?
Yeah.
Yeah. Sorry.
It's I don't know if you just like look at them and they're right next to each other on the thing. Or...
Oh no. Yeah. No. I just was trying to remember since I couldn't see them up above. We're okay there? Okay, so while these graphs can be points or lines or circles or all different types of things, we do not want to graph anything that is not given to us. So do not connect the dots unless you are told to, and we will talk about how we know we're told to do that later in the unit. Okay? Questions over those 4 representations? These 4 representations give us the exact same information, just with a different way of looking at it. So if I was taking a tally of this class and how many of you liked Brussels sprouts, right, I could then represent that information by just giving you numerical values. I could calculate percentages. I could do a bar graph and show how many were yes and how many were no's. I could do a pie graph and do what percent was yes and no. Right? All of those would be talking about the same thing, but just a different way of showing it. That's what these 4 representations are above. Okay, there is then other info that we can talk about with the relation, but it doesn't give us that same type of information as the other 4 options did. Okay, so another thing that we can talk about with the relation is domain and range. So new vocabulary. Right, the list kind of keeps growing. The domain is another word for our X values. And the students are like, okay, well then why do we need another word? The domain has a little bit more specifics of it. Okay, when we are talking about a domain, we have to list it in numerical order. I better write smaller. I wrote that X value is too big. No repeats. And here's my student's favorite. It has to go inside of braces.
part I always missed that test last year. I didn't put it in brackets or break.
Okay, this really isn't an option. It has to go in braces. Just like we write an ordered pair in parentheses, that's basically what tells us it is an ordered pair. Those braces tell us it is a set that belongs together. So students will then say to me, Mrs. McKinney, I'm really bad at making these. Can I just draw a parenthesis? No. Just draw an ugly brace. Make it squiggly something. It can look horrific. Okay? When I was your age, mine looked terrible too. I've been practicing for like 20 years. And sometimes they still don't turn out that awesome. Okay? It is a specific set notation. Okay, our range is in the same qualifications, but it's our y values. Oops. Ah. I mean, you can just put all of the above included. You don't have to necessarily write them all down if you don't need to. It's the same thing. It's just now our y values. In numerical order, no repeats, in braces. So here is what this means. On your test, when I ask you to list the domain, you will be getting a point that not only you know it's the x values, but that you know to list them in numerical order, and that you know that you shouldn't list repeats, and that you know you should be listing them in braces. So I mean, if you know what a domain is, those should be super 4 easy points. If you don't know what a domain is, that's gonna be bad. Yes?
If there's no repeats, then how do you do like 4, 4? Or something?
Yeah, I'll show you here in a second.
So basically,
I think I understand what you're saying.
you know that domain is the x value and range is the y.
Yep, and that you have to list them in a specific way. So if you're confused of which is x and which is y, numerical order, numerical order. Okay, D before R, X before Y. So you'll also notice in that mapping up above on the top of your oval, I put in the word domain and range because we're listing the X values in numerical order with no repeats, right? Okay, so if we want to list the domain from the mapping already has it done for us other than it's not listed in braces. So if we look at that mapping up above, what were our X values?
-4, 1, 3.
-4, 1 and 3?
Oh, all together in just one.
Say it again.
I get it.
You got it? So what's our range?
2, 6.
2, 6, 7. Yep.
When you say no repeats, do you mean if there's like another ordered pair and it's like another one is -4, you can't put that in?
Yeah, I'm going to show you here on this next one.
Okay.
Okay, so if we look at this one below, if we want to list the domain for example 2, so our X values are all of the first numbers in the coordinate plane. So here's an X value, X value, X value, X value. So if we're going to list these, we need to be in braces. What's the smallest one?
-3.
-3. What am I going to list next?
2.
2, not -3 again. Because I can't list its repeat.
7.
Okay, so for my range, what am I listing first?
5.
5. What am I listing next?
6.
Right? Not the 5 again, because no repeats.
9.
And then 9. Okay, so here's the thing that we should notice. If we are looking at these 4 terms on the top of the paper, we can fluidly go in between all of these forms. Right? If I gave you ordered pairs, you could turn it into a table. If I gave you a table, you could turn this into plotting points. If I gave you a mapping, you could go, oh, that's the ordered pair, -4, 6. Right? Those all go in between each other. As soon as we list out the domain and range where we were at down here, see if I can pull this up right again. Nope, not quite. Right? Once I do this, I can't go from here back to here. Okay, are we okay on that? Okay, then flip your paper over. We're almost done. A little bit here, maybe. So everything that we just talked about still applies. Okay, a function is a relation. It is just unique. It has a unique characteristic. A square is a rectangle where all of the sides are equal. Okay, so all of the rules we talked about are still fair game. Functions are just unique, and there are some extra things that we can do with them, which we'll be working on as we go forward this week. Okay, so a function is a relation in which each element of the domain, so each x value, is paired with exactly one element of the range. I sound like an elephant, but I don't know what that was. No idea. Probably a timer in Mr. O'Neill's room. Anybody think they know what this fancy definition tells us? Each element of the x can be paired with one element of the y.
You're just gonna have one.
Aaliyah?
The other distance of the other dot.
I mean, we can do it when we're talking about the points. Can we explain this in maybe like a elementary level?
Yes, please.
No.
You want me to do that for you?
Yeah.
That's a really fancy way of just telling us the x value can't repeat. Right? Because if an x value is paired with more than one y value, we would have to use it twice. And that's not good. Okay, so like a square has to have 4 equal sides, a function has to have no repeats in the x. Okay? So the question is then not, is it a function or is it a relation? That's not the question because they're not two separate buckets. They are all relations, and we're pulling one out and saying, yep, that's a function. Nope, that's not a function. Right? It's a yes or no question. So if we look up here at A, and we want to decide if it is a function, the only thing that matters is if the x value repeats. So we're going to look at all of the x values. X. Do we see any repeats in the x values?
No.
Nope, these are all different numbers. So 2, 3, 5, -1, 4. Here's even a better one of my students. They really love this question. Does the x value repeat? No. Is it a function? Yes. It's a backwards question. So we would say, yes, this is a function. Yes, Christy?
Why is it a -2?
Yeah, I asked that. I was doing -2. But there's no.
And like the ovals, it's a -2.
Oh, no. This is a totally different problem.
Oh.
It's not like the other side.
doesn't repeat, it's a function.
Right. Does the x value repeat? No. Is it a function? Yes. It's a backwards question. Drives my students bonkers. Let's skip and look at C. It's a little bit easier to look at next. I should have done a better order. So which side is the x values?
Left side.
The left. So we're going to look here.
Yes.
Do the x values repeat?
Yes.
Yes. So is it a function?
No.
No. So this is not a function. It's still a relation. They're all relations. Okay, now B, letter B. Does the x value repeat?
I want to say yes.
The x value?
Would
Oh,
we
wait, no.
see a repeat?
No.
Because what was the rule?
It does repeat. The one and the negative
No,
one and the
the-
negative 2 both go to -5, so that means they're
No.
No,
Yeah, that's the y value. Okay, but that was exactly what we needed, Charisma. That was the exact thing. This is repeated because it has two lines. Now, we just don't want the y value, so we need that same thing for the x. So do any of these have two lines?
No.
No. So is this a function?
Yeah.
Yes.
What?
Does the x value repeat? No. Is it a function? Yes. It's a backwards question.
So just the y values can repeat, but or just
Correct.
the x values.
Correct. The y values can be the same a bajillion times.
Oh my god, I just feel like I'm out of breath from like screaming.
Graphs give us a little bit more of a tricky thing because we don't see numbers at all, right? But there is a way to do it. Sorry, let me fix this. Graphs, we use something called a vertical line test. Mathematicians are super duper creative people. Stop deciding before you've even done anything.
No, I did this last year.
Just breathe. Yeah, but I didn't teach it to you. You're underestimating my awesomeness, so just like
I don't know.
chill for a minute.
Awesome.
Yes, hey, Kaylee?
Oh no.
No, you okay? Okay, so vertical line test says we want to see if we can find any vertical line that will touch the graph twice. Which way is vertical? Up and down. So my suggestion is to take your pencil and lay it on your paper. I'm going to take the edge of this because my pencil isn't getting long enough. Okay, and you're going to start sliding it across vertically
Yes.
and see if it ever touches twice.
Yes.
Do we agree that I'm touching the graph twice right here?
Yes.
How?
Just like,
I'm touching the graph right here, and I'm touching the graph right here.
what?
See how I'm touching the graph in those two
Oh,
places on
yeah.
the edge? Okay, so did I touch the graph twice?
Yes.
So is it a function?
No.
No. That wasn't that bad.
Just like, okay, last year the teacher never explained like why she was
You were
saying the
underestimating my awesomeness
pencil. I
here.
didn't go
Hold
there
on, what do you
last
mean?
year, so
What do you mean by like it's touching the graph?
Okay, so I want you to imagine this as a vertical line. The edge of my paper. So I'm constantly making vertical lines. Do you see how I found a vertical line that touches the blue graph twice?
Oh yeah. Okay.
Okay, does that make sense? Okay, so here we go. Once, I have to kind of adjust because my page isn't long enough. Once, so does it touch the graph twice?
No.
So is it a function?
Yes.
Yup. Once, Does it ever touch the graph twice?
No.
Nope. So is it a function?
Yes.
Yup. Oh, I actually wrote yup there.
Yup.
Yup.